Paper planes look simple. No engine, no fuel, just paper. But here's the crazy part. The same physics that keeps real airplanes in the sky also makes a paper plane fly. So today, we're breaking down the real science behind paper planes and why some of them fly farther than others. To understand paper planes, we first need to understand flight itself. Anything that flies depends on 4 forces. The first one is lift, the second is gravity, the third is thrust, and the fourth is drag. A jet engine creates thrust. A bird uses its muscles. A paper plane doesn't have either of those. Your throw is the engine. Gravity is constantly pulling the plane downward. Your throw pushes it forward. The air resists that movement, which creates drag. And the wings create lift. Flight happens when all these forces stay in balance. Now let's talk about lift, because this is the most important part. Lift comes from the way air moves around the wings. As a paper plane moves forward, air travels faster over the top of the wings and slower underneath them. This creates lower pressure on top and higher pressure below. That pressure difference pushes the plane upward. This is why shape matters more than speed. Even flat wings can generate lift. But there's one critical factor: the angle of attack. If the angle is too high, the plane stalls. If the angle is too low, there isn't enough lift. This is also why folding style changes everything. Not all paper planes fly the same, because folding controls wing area, weight distribution, and overall stability. Planes with narrow wings fly faster and usually travel farther. Wider wings slow the plane down, but help it float in the air longer. Adding a little weight to the nose makes the plane more stable. But if the back of the plane is heavier than the front, it crashes quickly. Now let's talk about drag, the hidden enemy of flight. Drag is the air fighting back. More folds create more drag. Sharp, clean edges reduce drag. And good symmetry keeps the flight stable. Think of drag, like running through water instead of running through air. You might have noticed that some paper planes loop while others dive straight down. If a plane keeps looping, the nose is usually too light, or the angle is too steep. If it dives straight down, the nose is too heavy, or there isn't enough lift. That's why small wing bends matter. They act like control surfaces. This is the same way pilots trim real airplanes to keep them flying straight. Now here's something most people get wrong: the throw. Speed matters, but angle matters more. The best throw is smooth, with a slight upward angle and not full force. Too much speed actually increases drag and makes the plane unstable. And finally, paper planes aren't just toys. NASA and universities use simplified gliders to test real aerodynamics. They study stability and how small control surfaces affect flight. Paper planes are cheap, easy to predict, and surprisingly accurate when it comes to physics. So a paper plane doesn't fly because it's light. It flies because air moves, pressure changes, and forces stay in balance. Every throw is a physics experiment in your hand. And the next time you fold one, you're not making a toy. You're building a tiny aircraft. It's not just simple paper. It's serious science. Thank you for watching. I hope this will be helpful for you. So please subscribe and turn on bell icon and being updated with science and technology.